Hello, hello, hello! It's chemistry time! Welcome to another video. In this video, I will be giving you tutorials on how to solve problems regarding ways of expressing concentration, colligative properties of solution, and thermochemistry. There are many ways of expressing concentration. One of them is molarity. What is molarity? Molarity indicates the number of moles of solute per liter of solution. It can be used to calculate the volume of solvent or the amount of solute. This is the formula for molarity. M is the molarity, N for moles of solute, and V for the volume of the solution in liters. Let's have a problem to solve regarding this topic. What is the molarity of 2.65 grams of sodium carbonate dissolved in 200.0 milliliters of solution? The given mass of sodium carbonate on the problem is 2.65 grams. The volume of the solution is 200.0 milliliters. Let's get the number of moles of sodium carbonate using the given mass. Before that, let's find the molar mass of the solute. The atomic weight of Na is 22.99, carbons is 12.01, oxygens is 16.00. We have to multiply by 2 to the atomic weight of Na because it has 2 atoms in sodium carbonate, 1 atom for oxygen, 3 atoms for carbon. The sum of these 3 is 105.99 grams per mole. That is the molar mass. This is the molar mass triangle. To get the number of moles, we have to divide the mass by molar mass. 2.65 grams divided by 105.99 grams per mole. We cancel the grams, then divide. The answer is 0.0250 moles of sodium carbonate. The unit of the volume should be in liters. To get that, 200.0 milliliters times 1 liter divided by 1000 milliliters. Cancel the ml, the answer is 0.2 liters. After this, let's use this formula to get the molarity. 0.0250 moles of sodium carbonate divided by 0.2 liter. The answer is 0.125 moles per liter or 0.125 m. There are many colligative properties of solution. One of them is boiling point elevation. Boiling point elevation occurs when the boiling point of a solution becomes higher than the boiling point of a pure solvent. This is the formula for boiling point elevation. Delta T is the change in boiling point, K sub B for boiling point constant, small letter m for molality, and I for Van Hoff factor. Let's have a problem to solve regarding this topic. What is the boiling point elevation when 147 grams of lactic acid is dissolved in 0.647 kg of cyclohexane? The boiling point constant of cyclohexane is 2.79 degrees Celsius per molality. The boiling point of cyclohexane is 80.75 degrees Celsius. The molar mass of lactic acid is 90.09 grams per mole. First, we have to find the molality. To find molality, we have to divide moles of lactic acid by the kilogram of cyclohexane. For us to get the moles, we have to divide the given mass, which is 147 grams, by the molar mass, which is 90.09 grams per mole. The quotient is 1.63 moles of lactic acid. We can now find the molality by dividing the moles of solute by the kilogram of cyclohexane, which is 0.647 kg. The quotient is 2.52 molality. Since we found the molality, we can now find the boiling point elevation. Using this formula, K will be 2.79 degrees Celsius per molality, which is the boiling point constant of cyclohexane, multiplied by 2.52 molality, multiplied by 1, which is the Van Hoff factor. Cancel the m, then multiply. The product is 7.03 degrees Celsius. This is the boiling point elevation. If you want to find the new boiling point, we have to add 7.03 degrees Celsius to 80.75 degrees Celsius, which is the boiling point of cyclohexane. The new boiling point would be 87.78 degrees Celsius. In thermochemistry, we have the first law of thermodynamics. The first law says that the internal energy has to be equal to the work that is being done on the system, plus or minus the heat that flows in or out of the system and any other work that is done on the system, said by a physics professor in Missouri State University, Saibal Mitra. This is the formula for calculating the change in internal energy. Delta U is the change in internal energy, Q is the heat absorbed, and W is the work done by the system. This is the formula for calculating work. W as work, P is the pressure, and delta V is the change in volume. This is the formula for calculating heat. Q is the heat, C is the heat capacity, delta T is the change in temperature. Let's have a problem to solve regarding this topic. An unidentified gas expands in volume, doubling its initial volume, 3 liters. It expands against a constant pressure 1.380 m at constant temperature. It absorbs 123 joules of heat that came from its surroundings at the same time. Calculate the work done in joules and the change in internal energy. We have the initial volume, 3 liters. The pressure is 1.380 m. Heat absorbed is 123 joules. We should find first the change in volume. In the problem, the final volume is double the initial volume, meaning we have to multiply the 3 liters by 2. The product is 6 liters. That is the final volume. Using this formula, we can get the change in volume. 6 liters minus 3 liters is 3 liters. That is the change in volume. We can now find the work. Using this formula, negative 1.380 m multiplied by 3 liters. The product is negative 3.9 liters ATM. The unit should be in joules. That is why we have to multiply it by 101.3 joules over 1 LATM. The answer is negative 395.07 joules. As you can see, it is negative. This means that the work is done by the system. Since we've found the work, we can now find the change in internal energy. Using this formula, 123 joules, which is the given heat, plus negative 395.07 joules, which is the work done. The answer is negative 272.07 joules. As you can see, it is negative. This means that the internal energy is released by the system. That's all for today. This is Hamdun S. Noor signing off.